Welcome to Full Stack TypeSafe Node.js. My name is Hassan, and today I'm here to talk to you about building full stack applications with end-to-end type safety in mind, specifically using GraphQL, TypeScript, and Express. So we'll first start talking about TypeScript, its benefits over JavaScript, and then move on to GraphQL, what GraphQL is, REST versus GraphQL, and then finally connecting TypeScript on the front end with GraphQL on the back end to make something with end-to-end type safety. And then finally, we'll live code the back end of a web application containing GraphQL, TypeScript, React, and Node. So let's talk about TypeScript. TypeScript is essentially JavaScript with static type checking added. A lot of developers tend to not like TypeScript when working with it for the first time because they see it as more boilerplate and defining types for every single variable you create. But as we'll see in a second, it's actually really great for developer experience and helps prevent lots of bugs. So this was a study done by IBM in 2008, which took a look at how expensive it was to fix a bug at different levels of the software development lifecycle. So at the design stage, how expensive a bug is to fix versus implementation, testing, and then in production, right? So they found that in implementation, it's actually 6.5 times more expensive to fix a bug than in the design stage. And when I say expensive, I really mean expensive in terms of hours or in terms of time, which translates to money. Right. And then in the testing stage, it's 15 times more expensive to fix a bug than in the design stage. And finally, in production, it's 100 times more expensive to fix a bug than in the design stage. And so TypeScript helps prevent a lot of these bugs, both with things like autocomplete or things like the editor just picking up an error and giving you a red squiggly line. So even before running your application, a lot of the time you'll get to fix a lot of these bugs that you might not see until much later down the line. Another great example of this is by Brie Bunge over at Airbnb. When they switched over to TypeScript, they did a postmortem and they basically concluded that 38% of their bugs were preventable with TypeScript, which is very, very impressive, especially considering this is Airbnb, who are known for their code quality and rigorous testing of applications and everything like that. So if a big company like that found this much benefit in using TypeScript, you probably will too with whatever you're doing. And finally, developers just love TypeScript, right? In the Stack Developer Survey in 2020, it was found that the TypeScript is the second most loved language. And then also, if you just look at tech Twitter and God forbid someone posts a screenshot of just JavaScript and not TypeScript, you'll get tons of devs commenting about why they didn't use TypeScript and all this stuff. But jokes aside, developers really love TypeScript, and its benefits are really clear with regards to developer experience and preventing bugs. So now let's talk about GraphQL. So GraphQL is essentially a query language for building APIs, but before we get more into that, let's just talk about the client-server architecture that we all know and love. You have some sort of client, some sort of front end that needs to talk to a backend or a server. And so to communicate, they need some sort of protocol. And at the highest level, this protocol is essentially REST or GraphQL. But before even getting into those two, just looking at the protocol itself, type safety is a really big part of the protocol. And to demonstrate this, let's just go through a really quick example of some sort of scheduler, right? Something like Calendly, where someone on the front end is going to indicate a time, and then we want to send that time from the front end to the back end. Right, we have to think about the format of that, right? Is it going to be a string? If it is a string, is it going to be an ISO timestamp, or is it going to be in a different format? Or the point is the front end and the back end really need to agree on what type the data is going to be and be able to detect if it's the wrong type and send some sort of error message rather than just crashing or causing weird bugs. So that's why type safety is really, really important, and that's really what GraphQL gives us. So diving a little deeper into GraphQL, let's start at the top right over here. GraphQL essentially lets you define all these different types. So here we have an office connection type, and it has these specific fields. We have a total count field, which is an integer. We have a nodes field, which is an array of this other type called office. So we can have types inside of types. And then if we go down to office, we'll see that it has two fields. It has an ID, which is of type ID, and that exclamation point means that it's required. And then we have a name, which is of type string. So you essentially get what it is. There's a bunch of these types, and we have these two things called queries and mutations. If we look at the traditional CRUD model, a query is the R in CRUD, it's for reading, and then a mutation is for everything else. It's for creating, updating, and deleting. So we can see this specific mutation creates a new office, and then this query just queries companies. And so these mutations and these queries, along with resolvers, which we'll talk about during the live coding, combine to form a schema. So GraphQL just gives us a lot of advantages that Rust just doesn't have. Rust has these problems such as overfetching data. A lot of the time, the front end doesn't want to use all of the data that it queries from a RESTful API. And so what it will do, it will query all the data, and then it will selectively choose, after it gets the data. But the problem with that is it's just a bigger payload, it's more strain on the network, and it's overall just slower. And with REST, to avoid that, you just have to create a lot of endpoints. And for the backend developers, this is not fun, and it's just a lot of extra code. And lastly, there's waterfall requests, especially when you have a lot of nested data that's in JSON format. And then this again just slows down the network. So with GraphQL, you can kind of ask for exactly what you want. You can query specific things, and the front end has a lot of flexibility in getting exactly what they want. And because of that, you have fewer endpoints too. You don't need to ask for as many, and it's also strictly or statically typed. So let's talk about combining GraphQL with TypeScript. GraphQL, like we mentioned before, generates this schema. But how does this translate over to TypeScript, or how does this translate over to the front end? There's this really cool tool called CodeGen, or more specifically GraphQL Code Generator, which takes this GraphQL schema and can generate TypeScript types for the front end. This is really, really, really huge because it helps ensure that the types for the front end are equal to the types of the back end, meaning there's only one source of truth. You have your GraphQL schema, and then you just use your code generator tool to generate these TypeScript types. So the front end team knows exactly what to expect. There's only one source of truth, so there's never going to be a discrepancy between the two. And as a result, you just have end-to-end type safety and great developer experience. Okay, so let's get into our live coding portion. Before I actually start coding, I just want to say that this is the repo where all the code is, so feel free to go to it now to follow along or to just check it out at the end. All right, let's get into it. Okay, so here's the root folder for our demo application. It's split up into two folders. We have API and frontend. The frontend folder is a React front-end application, and that's already done because that's not the focus of this talk. We're going to be spending time in this folder called API. So this folder is where our GraphQL API is going to live. So we basically have an index.js, which is a Hello World Express app, and we have a JSON file which contains some mock data. So this is mock data from 100 different users, and it contains an ID, a first name, last name, email, gender, and IP address for each of them. So it's 100 over here. So I'm just going to be using this mock data instead of using a database that most people would do. So the idea is that we have this mock data. We're going to be creating a GraphQL API that can query it and also that can mutate it, that can create new users to this list of users. And then we're going to be consuming this GraphQL API on the front end and displaying the user information on a screen. So let's get started. The first thing we're going to have to do is spin up the terminal and install a couple packages. So we're going to want to npm install GraphQL and then express GraphQL right there. So let's install those two and then require them. in the app. So we'll say const GraphQL equals require GraphQL. Good. And then we'll do the same thing for express GraphQL. And from Express GraphQL, we actually just want to get one thing called GraphQL HTTP. Grab that function from it. Okay, and then from GraphQL, this is where we're going to grab a lot of the types. So let's just do that right here. So I'll just go ahead and close some of the stuff. So we'll say GraphQL, we want to grab the object type. Actually, let's do equals GraphQL so we can get some of that autocomplete. So GraphQL object type. We're going to grab GraphQL schema, grab, and then GraphQL int, GraphQL string, and then GraphQL list. There we go. So these are all the types that we're going to need. All right, so the general structure of our application, we're going to have a user type. So const user type. And this user type is essentially going to model what our data looks like. So this mock data, it's going to say that, oh, we have an ID, and this ID is of type number. And then, we're going to have a first name, and this is a string, and so on and so forth. So that's what our user type is going to contain. For now, I'll just set it to the string. We're also going to need to define a query, right, to query all the data. So I'll just call this root query. I'll just set this to query for now. And then finally, we're going to need to define a mutation. And so this is to add data to our database, or to our, in this instance, to the JSON file. So we're going to just call this mutation. And then, like I mentioned before, all of this is going to be used to construct a schema. So we're going to have a schema, and this is going to take in this GraphQL schema over here. So we're going to say schema equals GraphQL schema. And this takes two parameters, which is the query. That's going to be our root query, and then our mutation. So it's just going to be mutation. Great. And then we're going to consume this with Express. We're going to be using, let's actually do that now, app.use. We'll specify a route. So we'll say GraphQL endpoint. And then we'll use that GraphQL HTTP function that we imported from Express GraphQL. And so that just takes in our schema, and it also, we can indicate this GraphIQL, which is a GraphQL user interface that lets us, just do sample queries and see what we get, which is really great. So we're going to set that equal to true, so we can play around with that at the end. All right, so this is the general structure of what it's going to look like. Let's go ahead and fill out these three. So for user type, we're going to say new GraphQL object type. And then this here takes in a name. So our name, let's just say user. And then it'll take in fields. So this field will actually take an anonymous function. Anonymous function over here. And then here's where we define all those types. So we'll say ID. And then our ID is of type integer. So we can say GraphQL int. And then we can go ahead with first name. The type for this is just going to be a string. So we can say GraphQL string. And then all the rest are going to be strings. So I'll just duplicate this and fill them out. So we have first name, last name, email, gender, and IP address. All right, so we'll fill those out. Last name, email, gender, and IP address. Address. All right, great. So that is going to be our user type. So going down to our query, this is going to look a little bit similar. So we're going to do new GraphQL object type. And then this is going to have a name. So we'll say name. We'll just give it root query type. name. And then for the fields, here's where we define all the queries that we want. We just want one query to kind of just grab all the data. So we're going to just call that get all users. And this query will have a type of the data will look like this, right? So we can just say the type is actually a list of users that look like this. So we can say new GraphQL list, and then each of these lists will have this type, this user type. So that's the type. And we need to define a resolver for everything that we're doing. So for this query, we'll define a resolver. So we'll just say resolve. And this is typically where we would talk to the database and grab whatever data we want and then return it. But in this case, we are just using this mock data and we actually required it. Did we? No, we didn't. So let's actually require our mock data. So we'll say const, call it user data equals require, and then we'll say mock data.json. Great. So we'll just grab this, and that's what we want to return in this resolver. So we'll go ahead and just put return user data. And just like that, our query is done. All right. Last thing we have to do is our mutation. So we can go ahead and do that. So new GraphQL object type. And that'll kind of contain a lot of those same fields. So for the name, we can just say mutation. Mutation. For the fields, we want to define one mutation to create a new user. So we'll just call this one create user. The type is going to be, again, just user type. This is just going to create one user. So we're not going to have a list of user types like we had in the query. We're just going to have, a user type that we define. And then this one actually takes a parameter called args because we need to give it an argument for whatever user we want it to create. So these arguments are actually going to look like this exactly. Besides the ID, we'll automatically generate that one. But for these, we can just copy them, put them in as arguments. And then we can go ahead and write our resolver. So our resolver just takes in this args. And we basically want to add this user to our user data array. So we want to first generate an ID and then add all of these arguments. So the ID, we can see it starts at 1 and it just keeps going. So we can actually just take the length of this user data array and add 1 to it, and that'll be our ID. So over here, we can, we're going to be adding to that array. So we can just do user data dot push. And then we could do ID, and then it's going to be, we're going to grab the length, user data dot length, and then we'll just add 1. And then we'll just use the spread operator to just grab all these args and put them in here as well. Right, that's 3 dots. And that's it for our mutation. All right, so let's actually spin up this Express server. So I'm going to be using NodeMon. And NodeMon is essentially the same thing as Node, except it just listens for new things. Oops, we have to cd into our API directory. And then we'll go ahead and run that. And it's listening at localhost 4000. Great, so let's go to localhost 4000/GraphQL. And we get our little GraphQL playground, which is exactly what we want. This will just allow us to do sample queries over here and then see the output on the right. So let's just go ahead and start from scratch. And the great thing here also is we can actually look at our schema here. It says that, see, we have a query called root type query, root query type, and then we have a mutation called mutation. So we can click on this query and we can see that, oh, we have our get all users query. And that takes, or that returns a list of these users, which have an ID, which is an int, and a first name and a last name. So we can see our full query just by clicking around in this playground. So let's actually go ahead and query all of our users. So we'll set up a query, and then our query was get all users. So we can just do get all users. And then we can actually ask for exactly what data we want. So let's say we want the first name, we want the last name, and then we want the ID. So we'll run this, And there we go. We actually get our first name, last name, and ID for all our users, which is awesome. And we can, ask for everything else as well. We have an email, we have an IP address, and I think that's about it. I might be forgetting one of them, but yeah, you can see that it returns everything, which is wonderful. Okay, now that we've done the query, let's actually try to add a new user here. So let's try our mutation. So we'll go ahead and do mutation, and we can click on the schema over here. We can click on mutation. We can see that it says create user. So we'll just grab that. And then we can just define, the first name, last name, and email for a new user. So I can just go with mine. Hassan, last name, El Mghari, and then email, Hassan at Hey. Right, so we actually don't need to define all of these because they don't have an exclamation point next to them. So that's good enough. And then we can even return some as well. I'm not sure if we specified a return. No, we didn't. So let's go ahead and just return args here, the resolver of the mutation. We'll save. And then we'll go back and let's just return the first name and the last name. Cool. So let's run this. And there we go. Great. It says create new user. And then I see my name there. So it means it added me as a user. So let's go back and run. We'll comment this out and we'll run the query again. And we hopefully should see me at the end. So let's run, scroll all the way down. And there I am, added as a user 101. So we can see that this worked. So now let's actually, now our backend is done. We created a GraphQL API that can both mutate and query. So now we can actually just go on our front end and let's try to use this, this query over here for our front end and display this data on the page. So let's go over here to front end. I've actually done this, so I'll just show you what I've done. We have an app.tsx and index.tsx. Index.tsx is where we're using Apollo client to do this. So we're just pointing it to localhost 4000/GraphQL, which is our GraphQL API. We're wrapping everything in a Apollo provider. And then in our app, this is where we define our query. So we can see that it looks exactly the same as what we've been playing with, except it doesn't have all of them. We just query first name, email, last name, and IP address here. And then this is actually a TypeScript type. So this is an example of something that can be generated automatically using those code generation tools that I talked about. So, we only have the GraphQL schema as the single source of truth. And then here down in our app component, and you don't need to know anything about the front end. I'm just going to go over this just so you understand that whatever front end person can actually manipulate these queries based off of that single root query that we created. So here they're actually looping through all the data that we get and displaying data that we need. So here they're displaying the first name and the email. So let's actually spin up this React application. We'll cd into front end, and then we'll do npm start. Wait for it to open. And it failed to fetch. So let's go ahead and go to the console. Oh, blocked by the CORS policy. So we can actually just go back to our Express server and add that. We can npm install CORS, which I already did, but we can just go ahead and add that at the top. So we can say const CORS equals require CORS. And then we can simply just do app.use CORS. So this, what it basically does is it just enables CORS for all origins. So we don't get any of those weird errors. So let's go ahead and refresh this. And there we go. So we get our user, first name, and then the email address. And so to go back to our app.tsx, we can see that we don't even need all this info. We just need first name and email, right? So this is, we can dynamically modify the query and this still works fine. If we decide we do want the last name, we could just, add it in over here, and then we can display it over here as well. So let's say user plus, put a space, and then we'll put the last name. We'll save. and we'll go back here, and there we go. We get the first name and the last name. So you can see how dynamic it is. And actually for each of these users, I'm using that type that was generated, the user interface type. And so you can see if this type didn't exist, or if we used a type that didn't make sense, like string, we can see that there's a bunch of errors in our front end, which is wonderful. So that is about it for the demo. I hope you enjoyed and learned something from this talk. Thank you so much for listening, and enjoy the rest of the conference.